Okay, so in this tutorial, miscellaneous point zero, we're going to be talking about some more camera motion. And Sawyer brought this up. So Sawyer wanted to know how. So if this is here's our third person player. Now, if you recall, right now we have an empty game object, which follows which is exactly where the player is. It follows the player around, and it's called the camera rig, correct? And then a child of the camera rig, which is about this far away, is the camera. So, so we have our camera up here, correct? And this camera sees the player from far away, and um, because the camera is a child of the camera rig, when we spin if we rotate the camera rig around the y-axis, so when the camera rig spins, the camera spins in this bigger arc around the circle, right? So then all of a sudden we have a camera over here looking in towards the player from this direction, right? So that way, that way. So that's when we spin this. Now, what Sawyer wanted to do, um, I'm gonna stop doing that now. What we want to do now is we want to have the camera be able to rotate upwards and downwards, right? So the axis we want to rotate around for that is the x-axis. So we rotate around the y-axis um, to spin the camera in a circle like this. We rotate around the x-axis, so when we rotate this way, the camera rotates this way. Um, Now, one thing about third-person controllers is if we get all the way over here, um, the the picture is going to be upside down, right? Because you can see the camera would actually flip upside down, and also we don't really want to be able to go all the way under. So unlike with the y-axis rotation, which goes in a full circle around, um, we want to what's called clamp or limit the amount the camera is able to spin. So we can only move up and down these amounts, right? And so that is something called clamping, and it means that you can move freely between two values. So maybe negative 30 and 30. So negative 30 degrees down and 30 degrees up. You can move freely between those, but once you reach the maximum, you stay at that value. So the camera stops moving at 30 or stops moving at negative 30. Okay? So I'm going to show you that script first. Actually, I'm going to show you how it works first, and then we'll set it up together. So I'm going to go to my other scene. Save that. We'll come back to that in a second. So if I hit play, where's my game? Let's if I hit play, what you're gonna see is if I turn the camera left or right, it spins around the y-axis of the player. Now if I move down, you can see we start to look up. And if I can look up and down. Oops. Well, you can see here I'm sliding down, but I can't go any further. So I've clamped the camera motion. Now, the other thing that's happening is you can see the camera's moving in closer. That's something we're going to do next. But so let's set this up, and I'll show you the code, and then we'll get it all set up. So I'm going to go back to our other scene, and I'm going to show you the script, which should be open already. So this is the vertical camera controls script, and let's see if I can get the whole thing. Well, I need to close this. Sorry. All right. vertical vertical camera controls. Okay. So this is the vertical camera controls script. Let me make sure I get the whole class, and already it's broken again. Okay. Well, so you can see there's the top of the class, and there's the bottom. So I'm just going to keep. This is our whole class in between these two curly brackets. So the class name is up here. So we have 1, 2, 3, 4, 5, 6 properties. We have the start method, the update method, and this method here called clamp rotation around x-axis. Now, this clamp rotation around x-axis is pretty complicated math. Quaternions are ways of storing rotations in 4 values. So normally we store rotations in x, y, and z, but quaternions have an x, y, z, and w value. And I don't even fully understand how they work. But what we do here is we convert the x angle of our quaternion. We clamp it between our two angle values. And so this method is just used, you can see clamp around rotation around x-axis quaternion Q. You can see we just use this method right here. And the reason we broke this method out is for clarity, right? Uh, you can arranging the update function is a lot easier without all of this pasted right in here, right? Um, so yeah, that's why we would have this separate method here. Basically, then we have a bool um, called smoothing, which is defaulted to false, but you can set it in the inspector, which lets us uh, um, smoothly move when the mouse moves, or just more rigidly move exactly as the mouse moves. I have smoothing off, but you might want to mess around with that. And yeah, and then we have our target rotation, which is just getting set in the start method here, and that's so this doesn't return null. Um, yeah. What else? What else? I guess that's it for this script. So yeah, so just once you have this typed up, and I'll leave it here for a second. You have this vertical camera controls is what it's called up here. Once you have all this typed up, and remember this is the start of the class and that's the end of the class, so we're just typing in between those class brackets, and you should already have a start and update method, so you can use those. You just have to add this one method down here. Okay, so once you have that script done, um, what we're going to do is, and let me just go back to Photoshop really quick. So the camera is currently a child of the this this here, let me, oops, gosh, so here's our player, oops, and here's our camera rig object, which spins around this axis. The camera is a child of it, right? So the camera is a child, spins like this. Now we want a what we're going to do is we're going to create another object, which is our vertical camera rig, to allow the camera to spin around this way. Okay? And so what we're going to do is we want this vertical rig to always be perpendicular to the camera, right? Because we want the camera to, we don't, if it was like this and we spun it this way, the camera would move, I don't know, really wonky. So we always want this axis to be perpendicular to the camera. So what we're going to do is we're just going to child this axis to our camera rig. So when our camera rig turns, this this axis will also turn, right? You can see how this would turn all the way around to there, or back that way. Okay, and then we're going to child our camera to that. So we'll be controlling. Not only will we be the camera register our left and right motions, but it'll also register our up and down motions. So let's go back to Unity and let's find our player. Somebody on the scene. And where are you? Nope, not player. It's my cam relative player prefab. So I'm going to open that up. Here's my camera rig. I'm going to open that up. So I'm going to right click on camera rig and create empty. And so this is going to create an empty object with the exact position and rotation of my original camera rig. I'm going to name this vertical camera rig. Now I'm going to take my camera and drag it into vertical camera rig. Okay. So we have our camera rig, and then a child of that is vertical camera rig, and then a child of that is camera. Now on our vertical camera rig object, we're just going to add our vertical camera controls script. And so I've already set up these values in the script, but you can adjust them. Minimum angle I have is -30, maximum at 30, mouse sensitivity at 1, and smooth seed at 1 with smoothing off. So let's hit play. And yep, I can move down. So notice the camera is limited in its motion. That is because there's minimum and maximum values. I can change those. So if I went to negative, let's say 70 and 70, you'll see that we have a lot more range of motion. I can go all the way under the player. I can go all the way on top of the player, right? So notice how we're going through the floor. That's the thing we're going to solve next. And also, you might notice we're going through the walls here. Yeah. So let me see. Give me 1 second. Okay, I'm just going to keep going forward on this video. It might make it a little long, but that's okay. So the next script we're going to talk about is this camera raycast script. And I talked a little bit about this in class, but I just want to, oops. I just want to talk about it a little bit. Really quick, I'm going to add it there. Okay. Thanks. Okay, so really quick, I just want to talk about this. So let's get our player. Oops. This is our player, and this is our camera. Now let's say we get a wall between the player and our camera. All of a sudden, we're just seeing a wall and not our player anymore, right? So what we want to do is we want our camera to automatically move in front of the wall, right? And you should recognize that this is a very common function in video games. You have the camera get really close to the character if the character squishes it between itself and the wall. So what we're going to do that is we're going to have what's called a target position. So the camera is always trying to be at this purple dot. Okay. Now, then what we're going to do is we're going to do something called a ray cast, and we're going to check between the player, and the player looks like an olive, and the purple dot. So from the player pointing backwards in this direction, if we hit anything, for instance, if we hit this wall at this point, we're going to tell the camera to move to that wall, and that's going to move to that point on the wall. So another thing we're going to do is, and this is very common in video games too, say there is an enemy. Okay, I'm going to undo some of this. So say instead of the wall, we get an enemy between us and the camera. Now it would be bad, and here's our here's our goal point. It would be bad if we drew this if we were drawing this line to our goal point and it hit this enemy and the camera moved between you and the enemy, then you can't see the enemy. Then you can't attack it. So what we're going to do is we're going to take all of our walls and our floors, so our walls and our floors, and anything we don't want the camera to pass through, like a door, maybe a building, and we're going to put it in a special layer. So we're going to put all of this stuff in a special layer, which our raycast, it's called a raycast, is going to ignore anything except this layer. So it's just going to be searching for these anything in this layer. Um, so yeah, so let's go set this up. First, I'll show you the script. So here's our camera raycast. So, so just to walk you through it a little bit, we have one public property that we'll need to set up. That's our target. And so that's going to be what the camera's trying to look at. And that's going to be the player. Okay. We have our goal position. Remember we talked about that? We're going to automatically create our goal position based on where the camera starts. We have our layer mask, and that's a number that lets us know which layer to hone in on. And I'll show you how we set that up in a second. And we have something called a raycast hit. That's information about what our raycast is hitting. So when it hits that wall, we need to know where it's hitting that wall so we can move the camera there. Now when we start the game, we're going to create a new game object, which is going to be our goal position. Okay? So goal position is going to be this new game object is going to be assigned to goal position. Then we're going to set goal position where the um, camera is, okay, um, and then we're going to um, set the parent of the goal position to our object's parent. So that means that this goal position is going to be a child of our camera rig, just like our camera. So the camera rig is going to move the goal position and the camera the same. Okay. Um, so then in our update method, so we just have a start and an update. In our update method, first we're going to get the distance between the target and the goal position. Then we're going to do our raycast, which is physics.raycast, and this takes a handful of arguments. Let me delete this and see if I can find the one we're using. Here we go. So it takes a vector3, which is the origin. So we're going to start at the player. It takes a direction. So we're going to move towards the goal position from the player. So we want to go. Our goal is the goal position, and we're moving from the player. So that's what this subtraction does. Then we're getting our hit info. So we're having this method return us our raycast hit. Then we're setting the max distance, which is how far apart those things are. That's why we calculate this distance up here. And then we're adding our layer mask. And so that's going to make sure we only hit things in layer 8. This operation here is called a bit shift. It's what you use for masks. We can talk more about it someday. So if this raycast hits something on the layer, we're going to move the camera to the because the script is going to go on the camera, by the way, so that's why it's just transformed opposition to whatever the hit point was. Else, we're just going to move it to the goal position. Okay. So this is the whole script. Let's go set that up. I'll just leave this here for a second. Oh, this comment here is for debugging purposes. It draws this red line. So actually, I'll turn that on here. I'm going to turn that on. Yeah. So let's go to Unity, and I'll show you. I'm going to separate the game and the scene window so you can see our debug line. So in order to set up the script, we just have to add it to our camera. So inside the vertical rig, add component, camera raycast, and then we need to set up our target. which is our cam relative player. Okay, so that's all set up. And then it should just work. So let's hit play, and you can see up here in the top in the scene view that we have a red line drawn between the camera and the player. And when that red line, and so right now, here's the thing. Notice that the camera is not moving forward even though the red line is hitting the ground. That's because the ground has not been set up on our layer yet. So what we need to do next is we need to select our ground, and we'll just start with the ground, but we need to do this for anything we want the camera to not pass through. So we need to select our ground and add it to a layer. So I already created the layer called camera clip, but the way we create that is you click on the layer on any game object, and you go down to add layer, and it's going to open up all of our layers. And here, layer 8, added camera clip. Okay, and so layer 8, remember in our code, our layer mask is only looking for layer 8. Okay, so let's click back on the ground because it doesn't add it when you create it, and click layer and add it to camera clip. And I'll do it for the walls and the doors too, if I can, but the canvas is in the way. So I'll select these doors and these walls and add them to layer camera clip. No, only this object. Okay, so now if we hit play, you can see I got my red line there. Notice down here in the game menu window, when I move into the ground, the camera moves closer. And you can still kind of see through the ground, and that would just require some tweaking, which we can figure out. But for the most part, the camera is just not, the camera cannot pass through. And you can see, notice the line doesn't shorten. We keep checking to see when the camera can, to see when the camera, how far away the camera can go. And we want to keep it at that goal position, but we are moving closer. So, yeah, that is all for that. Let me know if you get stuck on anything. All right.